So Taylor series about, so this is an point you have to expand your function in terms of Taylor series. So our Taylor sum of that finite number put that first term as for x plus derivative then then 2 factorial and as a 4 will be derivative. What will be the consequences? There are finite number of terms. Because this is the Taylor series of the function y equals to x. So whatever we have as a function, we have to find a value of the function at a particular point, which about which point we have to expand it in terms of Taylor series. So this is the functional value at x naught. This is the first derivative at x naught. Then you have to subtract x minus x naught. So you see, this is on another function where we have the terms x minus. Everything is represented in terms of x minus x naught, right? So here we have x minus x naught to the power 0, here x minus x naught to the power 1, x minus x naught to the power 2, 3, and all these coefficients are actually constant. So if you replace the value constant, the derivative, and then derivative higher order derivative. So this is okay. Is
Ma'am, I think it's finished. Ma'am, I think it's
can you hear me?
finished. Start, ma'am.
Yes, you
Ma'am,
can.
it's
I can hear you.
Okay, so you can hear me, right?
Yes, ma'am.
Okay, so Taylor series is clear right now. Okay, so what is Taylor polynomial? Okay, see, this is Taylor series. So whenever you are asked to find Taylor series, you have to actually find out all these terms, so 3 or 4 or 5, 6 terms, and you have to put dot 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 dot. That will be the Taylor series. But if you are asked to find Taylor polynomial,
Okay.
then what you have to do? Okay, so Taylor polynomial the degree of polynomial that is will be mention your question. So I'm writing the nth degree Taylor polynomial. So it is nth degree Taylor polynomial, then it will be k equals to 0 to n up to n. Then it will be same like this, but you have to here put in place of infinity n because it is series. That's why it goes to infinity, and since it is polynomial, it will go to n. Okay, so if the question is fourth degree Taylor polynomial, then you have to put n. Okay, so you have to find here the symbol is also k because we'll vary k with 1, 2, and 5, and it will be x minus not to the power. So one thing which you have to remember always, that is, in the case of Taylor series, you need not to find out the final terms, I mean the last term. Okay, you need not to go to there. You just have to first 6 or 7 terms, then you have to put dot 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 dot. That will be enough for case of Taylor series. But if it is Taylor polynomial, go to that means term. So this is equals to,
Ma'am, I didn't quite understand the formula. I mean, what does A represent? There was
functional value at
There
x
was a formula like a divided by 1 minus r.
x naught. Then first derivative at x minus naught second derivative. What does it mean? What say? Okay, so 30 minus x about divided by 3 factorial, and then there will be some terms, and finally it will be the nth term, means the nth. So what you didn't understand, Tanvir?
The formula. I mean, there was a formula, right? Like
Are you
a
clear now
divided
about
by.
tail polynomial?
Could you repeat?
I didn't use here any formula like a divided by something, right? I didn't apply anything like a. Is there any a? I used here x naught as a particular point with which around you have to actually express your function or expand your function.
Okay, okay, okay.
It is x naught. X naught means a point where you have to actually about which point you have to represent your function in terms of Taylor polynomial. So this thing actually mean, so I think I have to discuss more. And say have a function. Okay, so what why now we have this of Taylor is a polynomial about point. So this is x. Okay. You may see here x equals to a, whatever does matter. Here actually